Hello, everyone. This is Mr. Ruby on the Record, and this is my podcast for Potential Energy. Today I'm joined by my second period class. Hello, class. Thank you for joining me for this wonderful podcast on potential energy. Potential energy. In this chapter 1 reading, we will define potential energy, show how to calculate gravitational potential energy, and describe elastic potential energy. Identify other forms of potential energy. I must say, elastic potential energy is one of my favorite potential energies. The diver has jumped up from the end of the diving board. After she dives down and is falling toward the water, she'll have kinetic energy, or energy of moving matter.
That's so cool.
But even as she is momentarily stopped high above the water, she has energy. Do you know why? I know why. Because she has gravitational potential energy. Stored energy. The diver has energy because of her position high above the pool. The type of energy she has is called potential energy. Potential energy is energy that is stored in a person or object. Often, the person or object has potential energy because of its position or shape.
That's amazing.
Question: what about the diver's position gives her potential energy? Answer: because the diver is high above the water. She has potential to fall towards the earth because of gravity. This gives her potential energy. Gravitational potential energy. Potential energy due to the position of an object above Earth's surface is called gravitational potential energy. Like the diver and the diving board, anything that is raised up above the Earth's surface has the potential to fall because of gravity. You can see another example of people with gravitational potential energy in figure 1.1. Let's go down and see what that is. Oh, people on a sled and someone on a balance beam. Has anyone here ever been on a balance beam or a sled before?
No.
Excellent. Thank you for your input. Gravitational potential energy depends on an object's weight and its height above the ground. It can be calculated with the equation GPE. Consider the little girl on the sled in picture 1.1. She weighs 140 newtons, tiny child. And the top of the hill is 4 meters in height, and the bottom of the hill. As she sits on the top of the hill, the child's gravitational potential energy is GPE 140 newtons times 4 meters, or 560 newton meters, or 560 joules. Notice that the answer is given in newton meters, which is the SI unit for energy. A newton meter is the energy needed to move a weight of a newton over a distance of 1 meter. A newton meter is also called a joule. Question: the gymnast on the balance beam pictured in figure 1 weighs 360 newtons. Wow! If the balance beam is 1.2 meters above the ground, the gymnast's gravitational potential energy is calculated as follows to 432 joules. This next part is the exciting part: elastic potential energy. Potential energy due to shape is called elastic potential energy. This energy results when an elastic object is stretched or compressed. The farther an object is extended or compressed, the greater the potential energy is. A point will be reached when the object can be stretched or compressed anymore. Yes, question? You want to go to the bathroom in the middle of my podcast? That sounds fantastic. Be sure to sign out. I'll put this whole thing on YouTube, just as messy as it is.
You should.
I shouldn't. Okay. Look at the pogo stick in figure 1.2. Anyone on a pogo stick?
Yep. No.
No? So want to bring in a pogo stick and be very dangerous on it.
I had one, but I dropped it on the ground.
What's the clapping for?
Because it's a podcast. Who doesn't clap on a podcast?
Oh, excellent. All right. Way to leave off.
Elastic potential energy, I believe.
Thank you.
Why is there a Minecraft cave from happening? We're not in a cave.
I don't know. Potential energy due to the object's shape is elastic potential energy. The energy results when an elastic object is stretched or compressed. The farther the object is stretched or compressed, the greater the potential energy is. A point will be reached when the object can't be stretched or compressed anymore. Then it'll be forcefully returned to its original shape. Look at the pogo stick in 1.2. Could I have it quiet on the set, please? Thank you. Its spring with elastic potential energy is pressed down by the boy's weight. There we go. That's closer.
Thank God.
What? Do you want to come up here?
No.
Do you want to read with me?
No.
You can if you want to.
No.
Anyone else want to read with me? You want to come join me?
No.
All right, ladies and gentlemen, we have a guest reader. All right, where are we going to start reading?
So where do we leave off?
Let's start with this pogo stick I keep trying to read.
Okay. Look at the pogo stick in figure 1.2. Its spring has elastic potential energy. When it is pressed down by the boy... Oh, we already read this.
Yeah, keep reading it.
Okay. When it is pressed down by the boy's weight. When it can't be compressed anymore, it will spring back to its original shape. The energy it releases will push the pogo stick and the boy off the ground. Question. The girl in figure 1.3 is giving the elastic band of her slingshot potential energy by stretching it. She's holding a small stone against the stretched band. What will happen when she releases the band?
Answer. The elastic band will spring back to its original shape. When that happens, watch out! Some of the band's elastic potential energy will be transferred to the stone, which will go flying through the air. You want to try this tomorrow? I'll get out some slingshots and see what damage we can cause.
Yeah.
Yeah, we have some target practice.
Sounds great. Do you want to keep reading?
Yes.
All right. Other forms of potential energy.
All of the examples of potential energy described above involve movement or the potential to move. The form of energy that involves movement is called mechanical energy. Other forms of energy also involve potential energy, including chemical energy and nuclear energy. Chemical energy is stored in the bonds between the atoms of compounds. For example, food and batteries both contain chemical energy. Nuclear energy is stored in the nuclei of the energy atoms because of the strong forces that hold the nucleus together. Nuclei radioactive elements such as uranium are unstable, so they break apart and release the stored energy.
Well, thank you for being a guest reader.
You're welcome.
And drop the mic.
No, I didn't.
Oh, and there's the girl with the elastic. Oh, she looks like she's up to mischief. That looks mischievous right there. There's your summary. Potential energy is stored. Gravitational potential is due to the object's position. Elastic is due to shape. And chemical energy is a form of potential energy. There's our review questions. And this has been a podcast that's going on YouTube. So it's not really a podcast. It's actually a video. So check me out on YouTube at Mr. Ruby. Charles Ruby on YouTube. And this has been Ruby for the Record. Have a good day.